next is something called Latimer diagrams. This is a sequence of redox changes when involved. Then for a particular intermediate change, what is the EMF involved, how to find the EMF, and the intermediate change is disproportionate or not, or which direction of the reaction is feasible or not feasible. All this we can understand using this Latimer diagram. Let us see what exactly it is. For example, if this is basically we use it for such cases where there is a sequence of redox changes, means one particular element. This is particularly useful in those cases where one particular element can exhibit variable oxidation states. For example, if you take the case of chlorine, Cl minus, oxidize it to chlorine, chlorine to ClO minus, ClO minus to ClO2 minus, ClO2 minus to ClO3 minus, ClO3 minus to ClO4 minus. Here this is minus 1, 0, plus 1, plus 3, plus 5, plus 7. And also we have, these are all of course oxidations, permanganate to manganate, manganate to Mn4, Mn4 to Mn2 plus. This sequence also if you take, here this is plus 7, plus 6, plus 4, plus 2. So, like this, and iron to Fe2 plus, Fe3 plus. So, when we have these kind of sequential redox changes, then to determine EMF for any intermediate change, for each change if you are given the values E1, E2, E3, E4, E5, like this, if the values are given for each change, then for example, if we want to determine E for this, how to determine that, or if this is given, then what is the intermediate for this? Suppose E2 is not given, then how to determine this? Any such intermediate changes to determine this Latimer diagrams is useful. Next, also a particular change, suppose for example Cl2 to ClO2 minus, is it disproportionate or not? Or sorry, here chlorine, on one side it is oxidizing to ClO minus, on the other side it can also reduce it to Cl minus, it is possible. But the question is, Cl2 can disproportionate, means simultaneously can it undergo oxidation and reduction or not, that also we can determine. That's now let us see how to do it. Cl minus gets oxidized to Cl2, Cl2 to ClO minus, ClO minus to ClO2 minus, ClO2 minus to ClO3 minus, ClO3 minus to ClO4 minus. When you see this sequence, for example, suppose if it is given that for a change chloride to chlorine, if the EMF is E1, chlorine to hypochlorite E2, hypochlorite to chlorite E3, chloride to chlorate E4, chlorate to perchlorate E5. These are the EMF. Now, first we are asked to determine Cl2 to ClO3 minus, what is the E. So, here the sequence is that here EMF is not an additive property. EMF is not an additive property, but thermodynamical properties like delta G, delta H, delta S, they are all additive. Delta G, delta H, delta S, they are all additive. So, what we do is the non-additive property we convert into an additive property, and from that again we get back the non-additive property for the required change. So, for example, like for now for Cl2 to ClO minus, as this is E1, for this you convert this E1 into a thermodynamical property, that is free energy. Determine delta G1. Delta G1 is equal to minus N1 F E1. Now, Cl2 to ClO minus is over. ClO minus to ClO2 minus. This EMF change is E2, and for this the free energy change delta G2 is equal to minus N2 F E2. From here to here the N factor is, here it is 2 into 0 and here it is 2 into plus 1. So, the N factor is 2. So, here N is equal to 2. 2F E1, and hypochlorite to chlorite, here also the N factor is 2. Here it is plus 1 to plus 3. So, N factor is 2 minus 2F E2, and chlorite to chlorate ClO3 minus. This is plus 3 to plus 5, N factor is 2. Here delta G3 is equal to minus N3FE3, that is again minus 2FE3. Now, what we require is add all the 3, then what you will get is chloride to ClO3 minus. Here it is minus 1 and here it is plus 5, and here the N factor is 6. Now, this overall delta G is equal to delta G1 plus delta G2 plus delta G3, which is equal to minus 2F into E1 plus E2 plus E3 by, because this delta G is equal to minus NF E cell, this is equal to this. So, from this what you can write is that here this is 6. So, E cell, now this E is equal to minus 2F E1 plus E2 plus E3 by NF, that is 6F. So, this is equal to finally E1 plus E2 plus E3 by 3. E is equal to E1, this E is equal to E1 plus E2 plus E3. So, this is what you have to write it down. Here this is, here this E1 is actually this E2. Okay. So, like this you can determine the E value for any required change. Now, also whether this chlorine can disproportionate to ClO minus to Cl minus or not, how do we know? For that, or Cl2 to ClO3 minus to Cl minus, that now let us see. Now, chlorine disproportionation to chloride and perchlorate, whether this reaction, we know that chemically this reaction is feasible in basic medium. Now, this is feasible or not feasible with the help of EMF values, how do we determine? Now, Cl2 to Cl minus to Cl2, it is E1. So, for this it is minus E1, and for this it is Cl2 to ClO3 minus, that is E2, E3, E4. So, this change is, here E is equal to, this is I will say some E, where this minus NFE is equal to, now this N is 2 into 0 to 2 into plus 5. So, this N factor is 10. So, minus this minus NFE is this change ClO3 minus is equal to, from here to here, like previously what we told in the previous board, that from here to here it is minus NFE, that is equal to minus 10 FE is equal to, from here to here n factor is 2 minus 2 Fe2 minus 2 Fe3 minus 2 Fe4. This if you have to take. Now, from this is equal to E is equal to E2 plus E3 plus E4 2F by 10F. So, divided by 5. Now, you will get this, right, fine. So, here whether this disproportionation is possible or not possible on the basis of EMF, how do we determine is that, now for the reduction, delta G reduction is equal to minus n factor for this is 2 minus 2F minus E1, that is equal to 2F E1. Delta G oxidation is equal to, now for this is E minus NFE, that n is equal to 10. So, it is minus 10 Fe. This E is equal to E2 plus E3 plus E4 by 5. Now, you take these two, delta Gr plus delta G naught, if this result is negative, then disproportionation takes place. Disproportionation occurs. Delta Gr plus delta Go, that is free energy change involved in the reduction plus free energy change involved in the oxidation of this chlorine, that is for this reduction and for this oxidation. From the values of E, we can estimate what is the net delta G, means for overall reaction delta G. This overall delta G is what we are determining here in terms of this. So, this delta G overall, if it is negative, then the reaction is said to be spontaneous and the reaction is said to be disproportionation, or in other words simple, that disproportionation reaction can occur under the given conditions. If this delta G is positive, disproportionation does not take place. Straight away we can comment on that. This is what is the use of Latimer diagrams. This way of representing the sequential changes which helps in determining the EMF of any intermediate step for any intermediate redox change is what is called Latimer diagram, and this is how we have to do the calculations.